So if you wish to share this presentation with anyone else that you know or watch it again, you'll be able to do that. We will send a follow-up email message after today's session to let you know how to access the recording. We also welcome your questions. So anytime during our session today, if there's something you want to ask, please do so. You can use the features of the Zoom interface to send us a question or a chat, and we'll monitor that and try to answer all the questions that we get. And if we don't do it during the session, we'll do that in a follow-up message to you. So without further delay, let me turn things over to our co-founder and CEO, Russ Tubner.
Thank you, Jerry, and thank you to everyone for taking a slice of your day today and spending it with us. I thought I would go on video just for a moment to say hello, let you know we really are, we really do exist out here somewhere in the virtual Zoom space. But today, James and I are going to demonstrate, both discuss and then demonstrate how you can use, or how easy it is to create business-oriented APIs to your existing CICS apps and data. That's our goal for today. It's a privilege to share this stage virtually with James. James has worked with so many of our customers, helping them implement their business objectives using our product called HB.js. My job for today is a bit easier, and that is my job is to just introduce who we are and what we do and kind of set things up for James. As an organization, we've had one particular mission for the last 20 plus years, and that is to create a new category of industrial strength integration software. And now, as you may have heard in a prior Zoom conference or webinar, we're very focused also in the analytics area and in a space we call integration analytics. We do all this on the with a keen eye toward industry standards and also wanting to exploit whatever the best technology under the covers of a Z mainframe is at a given point in time. That means zIIP enablement, that means exploitation of pervasive encryption, whatever it is, we know our customers care about that. They also care about making sure that we enhance their security model, that we lower their risk profile in everything that we do, because we understand that our job is to move your bottom line forward and help your business get to where you want to go. As I mentioned, today's webinar is really a follow-on to one we did a few weeks ago that was sponsored by Tech Channel. That was called Using APIs for CICS Modernization. It was a bit more of a global overview. Today, however, we're going to go dig down in the details. This is a how-to session. If you'd like to go back and review the other one, there's the link. It's on YouTube. And I'm not sure if that link is live or not, but feel free to click it, or I think you can actually go to YouTube and search for Using APIs for CICS Modernization. But like I said, today's a roll up your sleeves session. And with that in mind, I'm going to kind of set things up just a little bit for James. You know, as a refresher, I think it's so easy to kind of look at these two broad modernization strategies and kind of consider them to be an either or choice. Now, both of them are very true. And this is not just our opinion. This is the opinion of many people, and this data has been informed by lots of analytic research. And that is that the cost of replatforming is high, the duration of the project is long, the complexity is high, and frankly, the risk in a number of different categories is high. Modernization in place is low from a cost standpoint relative to replatforming. The duration of projects tend to be very manageable, very short. The complexity, frankly, as you'll see today when James does this demonstration, is really simple. And the risk is commensurately low. Now, again, I think it's really important to make sure that we're in sync. At least our perspective is that this should not be a false binary. It should not be that an organization is going to re-platform or do modernization in place. I suppose many organizations have gone down that route, but what I certainly want to leave you with today is the knowledge that our customers frequently use a modernization in place strategy to achieve incremental replatforming. And we'll talk about how we go about doing that. Key to our approach is to differentiate between two styles of application programming interfaces. One is a very technology-based approach, where the API that we expose to the outside world from the mainframe has all sorts of details associated with it that are either directly tied or reminiscent of the underlying implementation. In other words, let's imagine we have a COBOL program, just a single COBOL program, and we expose that across an API, and that API somehow reflects the data layout of a COM area. Well, that's clearly a technology-based API because it has exposed implementation details about a given function. You can see some of the attributes that, at least in our mind, are true for technology-based APIs. They are platform dependent. They tend to expose implementation details. Frankly, they're harder to use because now you have to have the API consumer kind of get their head wrapped around, to some degree, the implementation of the API. And it ends up entangling the consumers of the APIs with the components that service the APIs or fulfill the APIs. So we say that the coupling is at the implementation level. We do not think that's good. A business level API, and you'll see James kind of model this today, is one that's designed to be more platform agnostic. In other words, the API should not say, run program XYZ123 and pass it these input values. No, it should say, it should be styled around a business level primitive or activity that is relevant for whatever the application may be. Our customers would use our product, for example, to write a service that might be called Get Account Overview or Get Customer Synopsis, something that represents a real, a higher level of abstraction and certainly completely disassociated from the implementation. So the goal is to become platform agnostic, and create an API that can be driven by the workflow. Such APIs also require far less effort to use because people in the business understand Get Customer Synopsis, and they understand the attributes of customers for inputs and outputs. It allows organizations to more easily couple mainframe-based APIs with their normal course of business flow. Now, this is one of those charts we talk about a lot, but the key point is really on the title. And I won't belabor this because we need to get to James ASAP, but the key point is this: business level APIs create an enterprise pivot point. And when we say a pivot point, that means a technological point where where on day one, you can certainly fulfill the API with apps and data that may reside on your mainframe. But then because we have a business-oriented API, we can pivot, or you can pivot if you so choose, to an alternate expression of those apps or data. So when our customers use our product to create business-oriented APIs, what we see is that on the left-hand side is that they're far more readily able to optimize their existing suite of applications. They can evolve those applications far more easily because they have disentangled, they have decoupled technologically the consumers of the APIs and the implementation of the APIs, and it lets them avoid what we kind of humorously call application rigor mortis. That is, in our way of thinking, kind of the state that can evolve when an organization has exposed a mainframe application at the detail level to outside consumers, such that if they change the application, the integration will break. And it never fails that when organizations create that sort of tight, detailed bindings between mainframe APIs or programs and consumers of those programs or users of those programs, once they hit a certain degree of scale, everyone is absolutely afraid of changing or evolving the applications because of that tight coupling. You can see some of the others. On the cloud side, it obviously allows for easier extension. It allows for greater scalability. But again, we are Z advocates, and we build software that runs on IBM System Z. But we understand that our customers, for some aspects of their apps or data, do want to migrate some off, or maybe in some cases all. It's not our job to take a position on that. It's our job to provide technology that gives an organization a pivot point. So if they want to enhance and modernize on the mainframe, great. But if they want to use that API as a pivot point to migrate certain functionality off, then that API has given them the flexibility to do so. So as we say, loose coupling both reduces the risk and increases your ability to adapt. One of the things that I just wanted to summarize on is just kind of our philosophy, and you've probably figured this out already just from my introduction. But we believe very strongly in leveraging existing business logic that's running on System Z today. We live in the CICS world mostly, and we understand the significant investment that large organizations continue to have with their CICS-based apps and data. But also, I threw in here another point that is really important to us, and that is we also want to leverage existing connectivity infrastructure, such as IBM ZOS Connect EE. In fact, my friend Andy Papagiorgio, right after this webinar, is going to be making a presentation at Share, at the virtual Share show this week. And he's going to be talking about ZOS Connect EE and some of the exciting things that are coming down the road with it. So if you are going to Share, attending the virtual Share, be sure and check out Andy's session. Secondly, if the first one is to leverage, the second one is to deploy. Deploy these business APIs, expose them for the objective of extending the reach to cloud, mobile, hybrid platforms, because at the end of the day, our goal is to help you evolve your hybrid IT world, whatever it is today and whatever you want it to look like tomorrow. Our job is to help you get there. Let's move into the demonstration. And I'm going to set this up just a little bit with a diagram and then pass the ball to James. What we're going to be demonstrating is the use of our product, the HostBridge JavaScript Engine, or you could say the HostBridge Integration Engine. It runs on the mainframe, under CICS, and on specialty engines, on the zIIP specialty engine. What that means is whatever you use our product for purposes of integration, won't in any way impact your other mainframe software cost footprint or cost expenditures one iota. All of our software runs on the zIIP. Our job is very simple, conceptually at least, and that is that we want to act as that API edge connector, that API fulfillment layer, so that something on the left side of this diagram can send an HTTP request in, and that API can be fulfilled using whatever applications you have. And after 20 plus years, I think we've seen almost every type and variety. For many of our customers, what they're doing is they're using our product to solve this problem. And this problem is where you have something outside the mainframe interacting with a whole series of fine-grained programs or transactions on the inside of the mainframe. And all of these requests, all of this orchestration takes time and costs money. And as a result, the efficiency is low, the latency is high, and the cost sometimes is through the roof. Our approach is very simple. What we want to do is to do that orchestration on the mainframe. We want to eliminate all those requests that are flowing in and out and consuming both time and resources on the mainframe. Replace it with a single HTTP request coming in. We service that request using whatever artifacts you have, and then return a single response. Efficiency is high, latency drops through the floor, and the cost profile is far more scalable. With that, James, I'm going to turn this over to you and let you introduce the demo and go from there.
Thanks, Russ. Let me see if I can find the right screen to share here. Sorry, guys. I'm a little slow about finding the right one. Well, my problem was it was the very first one. So I'm going to do a live demo. I'm going to create a web service right in front of you. Normally I do this in an hour. Today I'm going to do it in less than 30 minutes. So it's kind of a high wire act. I'm not going to do quite everything that I do in the hour demo, but I'm going to get as close as I can. But I am going to build a fully functional web service. So before we fire off and get into the web service, maybe I better show you the app I'm going to work with. So I'm going to log into my CICS region. By the way, everything's live. Nothing's recorded, nothing's canned, and I'm going to start with a clean sheet. And by the way, if I pause every once in a while I'm typing this, because I can't do two things at the same time. And I want to encourage you guys to ask questions as we go through here. So I've logged into CICS and I pulled up a standard BMS application. The application is just what you would expect in a BMS application. This is a sample application from IBM that's probably 30 years old. And I can walk through this application, getting stock portfolio quotes by selecting one of my stocks and either selecting buy, sell, or get real-time quote. I'm going to get a real-time quote. And this is the screen where I want to get the data off of when I write my web service. And there's obviously certain elements that I want to make sure I get. I want to know the number of shares I get. I want to know the number of the value of those shares, maybe the current share price, little other things on here. Now, if I want to do this for all four of these stocks, that turns out to be quite a few transactions. I mean, starting this is one transaction by itself. And then I've got 4 transactions to get the stock quote. It's 1, 2, 3, 4. And then I got 4 stocks, 4 times 4 is 16, plus the 1 to start it, 1 to end it. I'm going to run through 18 transactions just to get this very simple stock quote for all 4 of my stocks. 18 screens I have to walk through. Now, we're going to go for something that looks like this to something that looks like, let's see if I can find the right tab here. Well, I guess I don't have the right tab open, so I'll open it. We want to go from something like that 3270 screen to something that looks like this. Now, these are exactly the same numbers that I was showing you on the 3270 app. Now, I've already written this web service, obviously. I'm going to create this web service in front of your eyes here in a minute. But I just want to show you that you want to have a web experience like this. Now, I'm not going to build the web application as part of my demo, but I'm going to build the API this web application is calling. And this allows me to get all my holdings, and it allows me to buy and sell stock. So I just bought and sell stock. I just ran 34 transactions just with that mouse click, because not only did I have to do the 18 transactions to refresh the screen, but I had to run 5 or 6 transactions for each one of the buys and sells I just did. I just bought shares in all 4 of my stocks. So 34 transactions with that mouse click. Now I've exposed that web service in such a way where not only can I use it here, but I could use it in something like Excel. If I do a refresh here, I'm getting exactly the same numbers that I just created over there. and I can buy and sell the stock and all the rest of those things. And so that's what I'm going to create. Before I leave Excel, there's a couple other things I want to show you. Not only can we do exercise applications, but we can also go directly at the data behind the application without going through a CICS program or an application that's already written. We can go through HostBridge that's running inside CICS right next to the applications, and we can make calls using the DB2 APIs in this case over to DB2 and pull back data from DB2. Now, this is standard Excel spreadsheet, and I just pulled back 1,200 days of stock quote data right here into my spreadsheet. And I can also read data out of vsam files just as easily. So if I shorten my key here on my vsam file and I do a get data of that. Now, each one row that you see here actually had to do 3 vsam reads, and my piece of JavaScript running inside of CICS was able to do those vsam reads, assemble the records, and return it back here in a form that Excel understands is able to process, which is Excel likes XML. So all of this is an XML conversation. So enough of that. I just wanted to show you some capabilities that I'm actually not going to write into the web service before we hop over and do the rest. So let's go back over here for one last second. Okay, we got 18 transactions we're going to walk through, a number of screens. We're going to get the quotes for all 4 of these stocks. Now, where do I do that from? We're going to do that from an Eclipse environment. This is regular standard Eclipse with a HostBridge plugin installed in the environment. So I'm able to use Eclipse to look at my host, see what services are on my host. And I'm going to show you how I make services and create services in just a second. But this is the interface. This is the plugin that allows me to do that. So when I create my JavaScript here in Eclipse and I execute it, it actually is executing in the host. It's not running on my PC. It's not running on some server in the middle. It's running inside CICS. So if I do a hello world here, let's put the current date in so that I can distinguish it from others. And I do a right mouse click here and I say execute. Well, that piece of JavaScript was sent to the host, syntax checked, compiled, and executed right here. I just ran and I got the results right back here. Now, if I want to deploy this as a web service, I simply right mouse click and say make. It's going to replace the existing one that I've got on my host already. I say, okay, go ahead and replace it. It was successfully built, so it's there. I can actually call this now as a web service. It did it right then. It's now a deployed web service. And I can call that web service from my browser, and I can get the results back here. Now, it's a pretty poor web service. It's not JSON or XML or anything like that, but it is a web service. I just wrote and deployed this callable web service to the outside world in 30 seconds. So you can write web services very quickly. So what does it look like when I write a web service? So let's start with a clean sheet. And we're going to write a web service. It's kind of a high wire act, doing this in 30 minutes, but we're gonna make it work. So first off, I'm going to capture the start time because I want to know how long does it take my web service to run. Now, we had to wrapper an assembler instruction to get the exact time that we wanted. We found that milliseconds wasn't accurate enough. We had to go down to microseconds. So that stickf is actually an IBM assembler instruction that we wrappered in the JavaScript so that we could call that and get the exact time in microseconds. And I want to set up addressability to my HostBridge object that allows me to run transactions. So we've written code, inserted it as part of the JavaScript engine. By the way, the JavaScript engine we're using is a JavaScript engine ported out of Firefox. So we're using a full-fledged JavaScript engine running inside of CICS. So I want to set up addressability so I can call the methods and functions that allow me to run transactions. And we've done that through an HB object. And I'm always worried that I'm going to misspell something. I'm a poor speller. So with that, I now can run HB commands, and I'll show you those in just a second. The next thing I want to do is I want to pull in some common packages of pre-written JavaScript. Now, we distribute with HostBridge quite a few different packages of pre-written JavaScript, things that help us do debugging or zero padding, things that are very common on a 3270 screen that are not very common in other places. We wanted to have some services already built in so that you could call those. Now, this is just straight JavaScript that I'm getting ready, this package I'm getting ready to pull in. There's nothing special about it. You can write your own packages for reusable code just like we did. And you can pull down and see our code that we've written in all of these packages. I'm going to pull in common, which has a bunch of packages in it that allow me to, like I said, do zero padding left and right and those kind of things. If I'm filling in a field on a 3270 screen, very often I've got to pad it one way or another. With that, now I've got addressability to that. I want a debugging package so that I can see what's going on. The debugging is the name of the package I'm pulling in. HB script is the name of the repository where that package is stored. Now, these repositories are nothing more than vsam files. We compile the JavaScript into bytecode and store them in vsam files so that you can use all your standard tools for doing promotion and migration from one environment to the other. I'm not going to go very deeply into that because we don't have time for that today, but we have dealt with all of those things before. As well as, I'm not going to discuss security very much, but believe me, we've gone through everything with security as well. We can make sure that your conversations are secure and the data that's flowing over it is private. Okay, with that, I've got my two packages pulled in. Now I'm actually going to use a couple of those packages, a couple of functions out of those packages. This is going to allow me to turn on and turn off debugging simply, and I'll show you what that looks like as I run through this. And we'll probably won't even have time to use this package, but just in case we do, I want to go ahead and include it. It provides me a bunch of error checking routines that allow me to make sure that my application is running as I expect it to. Now, I've written some lines of code here. Now, these really, they are kind of executable, so they can go wrong. So I want to make sure I haven't mistyped anything or done anything wrong in that short little bit of code. So I can actually execute immediately. And I didn't get any error messages. I'm not writing anything out. I'm not getting any error messages. That means at least this code is syntactically good. I want to be able to talk to my transaction and pull in that data and then give out a response to the outside world. Now, my response today, I think I'm going to use JSON as my output. And I want to kind of create a template of what that JSON document is going to look like. So I'm going to create that template by just creating a JavaScript object called response. And, you know, if we look at what I'm going to return back here, I want to return this quote information, and I'm going to do it for multiple stocks. So I'm going to have a quote section that then has these various elements inside of it. So let's go ahead and create an array of quotes. And I want to have a status section that says, how did my web service run? This is where I'm going to put the elapsed time of what I ran, how many transactions I ran through, did it run successfully, did I have any errors? So I'm going to create a status object. And in that status object, I'm going to have the elapsed time. And I'll set that to 0 to start with. And transaction count. Success. Did we run successfully? No, that should be set to false starting off with. The default value is false. And if we had any errors, and I want to make that an array because we might encounter more than one error. Okay, with that, I've got my template of what I want my output to look like. This is the template of where I want to start. So how do I turn this into my output? Well, it turns out to be pretty simple, and I'm just going to go ahead and add this section at the bottom. go down here a little ways. And so let's do this. We'll do, how do I output this? Common, and I'm going to do JSON. So it's going to be, and again, you can see I'm pulling this out of my common library. So this is another routine that we just supply. CICS has the ability to put headers on the output, and all I've done is wrapper the API that allows me to add those headers to the output from CICS. Nope, that's not what I want to type there. I want to do JSON. Another routine from my common. So with that right there, I'm taking this object and I'm going to convert it into JSON output. With that, I can actually run this. So let's run this and see what happens. I should get some output this time because I do have a write line in here. So if I say, oh, I did a make there. I want to do an execute. And here's my JSON output. There it is. Oh, and I left this as my hello world. Let me rename this real quick. We'll call it live demo 1. And let me make it now. So if I do a make on this, that has syntax checked, compiled, and saved this service on the host. So let's go over here and change my hello world to live demo 1, all lowercase. And looky there, I've already produced JSON output. Now I haven't exercised any transactions yet, but now I'm producing JSON output. Again, this is my host. I keep saying it because most people misunderstand that we're going to some sort of server in between or something along those lines. I'm talking directly to CICS when I make this call right here. All right, so we've got this. You know, it's time now for us to actually start running transactions. We kind of done this wrapper work, you know, what the output's going to look like and getting kind of set up at the front. But the next thing we need to do is actually start a transaction. How do I do that? Pretty easy. We use that HB session object we created up above, and I just say HB run, and I'm going to say what transaction I'm going to run, like that. And with that, I have a transaction in flight. There is now a transaction running. And now, where am I at? I'm on that very first screen. I'm on this very first screen here. This is where I'm at when I execute thread. Now, I've got to fill in fields on the screen here. This is a field right here. How do I fill these fields in, and what do they look like? Well, this is a BMS application. All BMS applications already have field names associated with them. They were created when the programmer wrote the application to begin with. I'm going to use those field names to access the various elements on the screen. To fill in fields, to extract out data, I'm going to use real field names. That means when the programmer changes the application, those fields will move around on the screen, but I don't care because I'm referencing it by a field name, not by screen geometry.
James, camp out on that just a minute and explain the implications of that, because the fact that our script, the fact that we live in CICS, kind of like right next door to this application, allows us to interact with the BMS application kind of in its native tongue, right? Because a BMS app doesn't think in terms of 3270 data streams. It thinks in terms of field name value pairs. Is that correct?
Absolutely. And we can actually see what those field name value pairs are by some of the tooling that we have actually right here in Eclipse. So if I double click default right here and I start my transaction, just like I did when I was on my 3270 screen, it looks like this is a 3270 screen. It is not. This is a recreation with HostBridge talking to the application, talking to the BMS interface, getting back the data, and integrating that data with the field names that are part of the BMS map. And that's done all dynamically on the fly. There's no setup ahead of time that has to be done. If you have BMS applications, we can access the field names from day one. So these field names allow me to interact with the application by field name. Changing the application has no effect, will have no effect on my services I create. You can still add fields, delete fields, as long as you're not deleting a field that I'm using. And the application, the web service I create will continue to work as is. And I don't have to be concerned about it. So you go ahead, update the application. If you need me to add new fields into my web service, yeah, of course I'll have to modify it. Or if you delete a field that I'm using. But if the fields just move around and you add other data that I don't care about, we're going to continue to work. Much, much less brittle. Okay, so this is my application. So if I want to know what field this is right here, I can actually see it right here. It's option. Well, let's just go ahead and walk through the application real quick. And I selected one there, and I'm going to select one here. And we can see the fields right here. And I'm just going to go ahead and back out of this again, all the way out to this. I'm going to then close this out and save it. And it's going to give it on an automatic date of today's date is the name. And I can actually go up here and reuse or review that that transaction I just walked through. All the fields are here. Every command that I inputted is here, and I can now interact with this, and I know what all my value, or my field names for my values are going to be. Usually when I write a web service for a customer, I have the domain expert sit next to me, and we walk through all the scenarios for a transaction, all the failure cases, success cases. The failure cases are actually the most important. And that means that when I go to write my web service, I've got all the information necessary to write a fully functional, hardened web service, something that's going to work day in and day out without any problems. So I now know all the field names on my screen. Here they are, user 41. Now, these are the field names chosen by the programmer when this application was written. Like I said, this is probably written by an IBM junior programmer 30 years ago. All right, so now I know the field name. So I can go back over here and I can start filling in field names as I walk through this application. So I can say HB set. And the first field I need to fill in was option, right? That was the first field we saw. And I'm just going to hard code a 1 right here for now. We're going to change this in a minute, but for right now, it's going to be a hard coded 1. So with that set right there, I've now set the field on the screen. And all I got to do is do an HB run. And I want to press the enter key. Now, obviously, any application, you can press PF keys, clear, attention, other keys. All of those can be addressed by using the HB_AID command. So I want to do an enter here. So I'm going to say HBID equals enter. Now, with that right there, I'm now on the second screen. And the second screen was this screen, right? Because I pressed enter, I filled in the value, pressed enter. So now I need to fill in this field. This field is called opt2. So I'm going to say HB set opt2, and we're going to put a 1 in there as well because we want to always get real-time quote. And after that, I'm going to do another HB_AID equals enter. So far, so good. Pretty straightforward. So now I'm on this screen. I'm on the next screen here. This is where I'm going to grab all these values off the screen. I'm on this screen right now in my web service. So let's go through and grab those, and let's just split my screen here. Wait, let's make this full screen first. Now I'm going to split my screen so that I can see both at the same time. And so the fields I want to get, well, first off, I got to stuff them in my response up here under quote, right? It's going to response, quote, and then my values. So I'm going to push these into that array. So response dot quote, that's what it is above. And I'm going to use the array push command, which is just standard JavaScript. And I want to push all the values that I care about. So we want to get shares held. So that's called, the field name is called held. So shares held is what I'm going to call it in my JSON. And the field is just held. Okay, so with that, I've grabbed my one field. Now, I'm going to go ahead and just duplicate this because I want to just do some more of the same. So what else do I need to get? I need to get the share price. Share price is over here. That's called share now. So share price. And don't be afraid if anybody sees me make a typo of correcting me. And what did I say that was? SHRNOW. And then we're going to get, let's see, what else do we need to get? We've already got held. Total value, and that's just called value. So let's just put value in here. And next, let's get the username. We're always going to be demo, but still user 41. And one more field. Let's get the company name, which is comp 41. With that, let me give this, update the field names here. Okay, so with that, I have pushed my response onto that queue that I'm going to output. And in fact, let's test it right now. Let's go ahead and do a make on this to make sure we've not created any errors. I have to get out of full screen mode first. And let's do an execute and see what happens. Oh, look there. There's my number of shares, share price. That looks right. Let's go ahead and make this. And we'll go over here and test it. I'll do a refresh on my browser. Hey, that's rocking right along. But no, that's only one company. And I'm not specifying which company I want. I need to be able to pass that information in some form or fashion. So let's go over here and make this a little bit more robust. But before we do that, we got to make sure that we back up again in our application. Right now, we're here on the screen. HostBridge does not change the flow or the workings of your application. No changes to your application on the host has to be made, but that means that we have to flow of the application as it was written. So I have to press the PF3 key here to back up and the PF3 key here to back up again to get back here before I select my next company. So we got to hit that PF3 key twice. So I'm just going to copy this.
James, as you're doing that, I just thought I would interject that, because you said it so well, we have to honor the flow of the application, the way it transitions from one screen to the next. And it sort of looks like that we are operating it as though we were a terminal. For example, you're saying PF3 or enter. But the reality is we have kind of a memory-to-memory relationship with this target transaction to where the 3270 data stream doesn't exist. It's never created as input for the application, and the application never creates it as output. We're just dialoguing with the app the way it was originally intended.
So I've added my two PF3s. And I've added a command for PF12. Now, the trader application, I can exit the application anytime by hitting PF12. And this delete session is kind of important because it cleans up all the HostBridge resources and we're out. So with one indication of this, we're going in, walking in those 4 transactions, walking back out and exiting the application and cleaning up. There is no state left on the host when I do this. So if I execute this again, just to make sure everything's still working, I still get my results, except now I've cleaned up my resources on the host. If you don't do the delete session, the resources get deleted after 5 minutes of that activity. Okay, so far so good, but now I need to figure out how I can pass in the company I want to use. I don't want to hard code the company I'm getting the value for. So, and if I pass in multiple companies, I'm going to want to be able to get all of those companies. So I might want to get all 4 of the companies. So I've got to figure out how to put this in a loop to do that as well. So first off, let's get the value from the outside world that's being passed in. We're going to pass the value out on the query string. It could be posted data, JSON document, any of those things. But for speed here, trying to get through the demo quickly, I'm just going to use the URL query string. So I'm going to create a variable called companies. And again, I'm using an HB object that wrappers a CICS API. So the parameter on the URL query string is going to be called companies, and I'm going to use a JavaScript method called split, and split everything by comma. That means, I better spell split right. That means that it will split based on the comma, and create an array of companies. Okay, so now companies should have the companies I want to retrieve. Now I need to create a loop here that's going to let me iterate over how many ever companies I'm going to process against. So I'm going to put all of these things in the loop. This HB run will be outside the loop because I only want to close things out at the end. So there's my closing bracket for my loop for you can always tell a live demo when I mistype so much.
James, that's okay. As you have those gaps, we're having quite a good conversation or flow of Q&A on the chat window. So you're spurring discussion.
Okay, so with that, I now have a loop that loops over companies, right? I'm looping over companies right here, which is the parameter that I just pulled those values in on. I'm going to loop over those companies. Now I need to change this to I, because no, not I, but companies. So I need to go companies. So with that, I should be referencing the array companies, and I'm going to be putting those values and passing those values into options. So companies will have values 1, 2, 3, 4 in an array, and I will iterate over those as I run through this. So I think this is going to work. So let's go ahead and run this and see what this looks like. I'm going to execute it interactively first. Uh-oh, I got an error here. HB request, HB get value is in error. So I must have messed up spelling something here. Yes, I did. No, I didn't. Let me what am I typing wrong?
As James is taking a look at that, there was a question that came in that I really liked. It was, what are some of the typical use cases where we can use this web service approach like this? Based upon our customer list, the options are endless. One of the nation's largest financial institutions uses our technology to be able to expose APIs to their middle tier web-based applications. So all their customers log on to a very sophisticated middle tier application on the web, and then those applications on the back end fire in API requests to our product. One of the largest insurance carriers or insurance administration companies in America has created a catalog of 250 to 300 different APIs that allow them to let either their web services or their web servers gain access to, or their supply chain or demand chain partners. So the use cases are as varied as your applications. Whatever makes sense for you to expose via an API given your business and your application domain, you can do it. James?
Yeah, my problem here is I was trying to get something off the URL query string and I was running it interactively. Well, I'm not passing a URL query string when I run it interactively. Once I added the query string here, I have to run it now from an external entity like this. So you can see that I just ran this and I got my results back. Now, that's the data live. And if I go back over here, there's a couple things that I'm missing. I didn't set the last two things, and I think I'm done. I need to set the tran count. And that's going to be HB tran count. And I need to set the elapsed time. That's going to be the current time minus the time we started at the top. Oh, and we should also if we got to this point, we know everything worked okay. So let me make this one more time. And with that, and refresh it one more time. And the only thing we should see added here is our elapsed time of tran count. And there it is. And again, this is in microseconds on our very small emulated ZOS system. So 93 milliseconds on our tiny system. This runs on a real Z hardware, probably in about 1 or 2 milliseconds most of the time. One other thing that I wanted to show you is I had that debug option that debug control that I added at the top. And I can add an option on the end of this. When I ran that, now nothing changed here, but if I go over here to my debug control window and I refresh this, this right here is every screen that I walk through. Every command that I entered, every field that I filled in. And this debug output was stuck out of band in another place so that I could retrieve it through this web application, which is part of the HostBridge distribution. So I can actually see what my web service was doing. So if I need to debug it and something goes wrong, it's relatively easy for me to do that. And I can talk to you a lot about how to do it interactively and how to do it actually in production and not impact production too. The other thing that's always a question, and I know I mentioned this earlier, is security. We know how to secure your transactions. We don't change the flow of your transactions. So your auditing and logging that you already have in place today still works. It's not going to change.
James, on that point, we had a great question that comes in. It would say, okay, now that we've done this and we've exposed an HTTP endpoint serviced by the mainframe in CICS, what prevents a denial of service attack?
Well, most of the time, your mainframe is behind, it's in the glass house, right? You're only going to allow ports to come in through the outside world. Only the ports that you allow to come in and from the servers you allow to come in. These services generally are not published directly to the internet. They're published to servers. Now, those servers may be in-house or on the internet, but still pretty directed on where they're published to. Also, the IBM, we're coming in through the TCP/IP web service definition, and it has a service denial of service protections actually on the TCP/IP service itself. So IBM has protections in place, but the best protections are going to be what ports you open and who you allow access to those ports.
Yeah, and I would just reemphasize to the questioner that, as James said, when you create APIs like this, virtually 98 times out of 100, if not almost 100, these APIs are being exposed to a web application that is also inside your organization. So your end users or customers, whoever they might be, are interacting with your web-based applications. Maybe it's running on Apache or WAS or something. And then those applications that are actually facing the outside world then are interacting with CICS-based applications across an API like what James has created here. We definitely demoed this, that we showed you how we can create a web page that can interact with this directly, but that's for demonstration purposes. 9 times out of 10, an end user is not directly interacting with such a service. it's through an intermediary agent of some kind.
We,
James?
we also we also had a question from Gary about pervasive encryption, and the answer is yes. The host supports SSL, the various versions of SSL, and it also supports authentication through X509 certificates, so you can have secure authentication as well as secure transport to the outside world. And we're not limited just to HTTP. That's all we've talked about today. But you can also invoke HostBridge from MQ, from other programs running inside the CICS. Or outside CICS just running on the host. But as far as encryption goes, yes, we work with encryption. Really, it's not our responsibility. ZOS and CICS take care of all of that before we actually get the requests, but we do support those types of encrypted requests.
James, once you've created a script like this, we had a question came in about, okay, now you have it. How do you do version control? How does this dovetail in with Endeavor, ChangeMan, Librarian, or Git?
Well, it's really up to you to decide which one of the ways that our customers have done version control. I have customers that use Git to do version control, and they do all the version control for all of the scripts off the host. And they have a process that allows them to make the scripts through a standard process that you would expect for version control off the host into repositories on the host. So it's managed and controlled off the host for the most part. But I've got many other customers that use Endeavor to do that. And because these are standard vSAM files, that means you can treat them just as you would any other vSAM file. And we've written batch jobs, batch routines that allow you to promote scripts from one environment to the next environment and put that batch job under Endeavor, say, controlled by Endeavor. So you can migrate your services and scripts from one environment to the next as you see fit. We've also got the ability to do rollback, so you can back out of an upgrade. And then I have other customers that have chosen to create a new vSAM repository with each set of versions that they're going to publish, so that rolling back or going forward to the next version is no more than changing the DD statement inside of CICS, which you can do dynamically inside of CICS to point to the new release of the new set of scripts you might be pushing. So there's lots of different ways you can approach this. We support version control on the host or off the host. It's really however you want to do it.
James, any final comments before we begin to wrap up?
The only thing I would say is we integrate with anything inside of CICS. Anything you can touch inside of CICS, whether it be a data source, a transaction, a program, doesn't matter if it's Convery or channels containers, anything that CICS can access, we can actually put a wrapper around and create a web service out of that, whatever it is. And we do it with no changes to the applications on the host.
Great, James, thank you for that demo, and thank you for walking that tightrope with us for a few minutes today. I hope that this has at least whetted your appetite for the art of the possible, what can be done. At HostBridge, we kind of look at a modernization journey as having a few different phases. First, actually, we start with a very analytics-oriented approach these days. We have a tool that allows us to be, or allows you to be able to see exactly what end users are doing, and maybe begin to identify those modernization priorities. Also, as we said, API design is very important to us. We are a strong believer that the APIs exposed should be business oriented, not technically oriented. And of course, API fulfillment is what we're doing with a product like James just demonstrated. HB.js is our tool to be able to fulfill a business level API with tremendous performance and scalability using your existing mainframe application artifacts. There are lots of resources out there that are available. Let me see if we can get the slides to advance here. They're on our website. as I said, a number of different ebooks on the general topic of optimization written by our friend Michael Benson, a guide to creating CICS web services. It's very helpful, kind of a written version of what you just saw, and a couple of specific documents like this one on the right, dealing with how HB.js can be used with ZOS Connect EE. As always, please feel free to reach out to us at info@hostbridge.com. We have a whole team of people who monitor that. And then, as I said earlier, there are a number of other resources. One in particular that's going to be happening very shortly is one by IBM and Tony Papagiorgio regarding ZOS Connect EE and CICS, to give you kind of an update on that. With that, we wish you a good day. Please feel free to stay in touch. I'm active on LinkedIn, so feel free to reach out to me there. And thank you again, and have a good day.